Welcome back to a lecture series on watershed generation from SRTM and contour data. Watershed generation from shuttle radar terrain mapping, and you can also take your contour. From this you have to prepare a contour and then you have to generate a watershed. This has a huge amount of application. You can also do this here, and then you can also see that suppose if you are making a 3D SRTM data in image processing also, there is a filling. Suppose if what amount of water is there, rainfall is there, and what stage it is filled also can be predicted. No, it's a 3D model, a realistic 3D model with respect to the accuracy of more than 98.99%. So it has a lot of application with respect to hydrogeology is concerned. We will see that how watershed generation using SRTM data from SRTM to contour, contour to watershed preparation. We will see it's a very good exercise for the water resource people, those who are working with water. What is watershed? Watershed is the upslope area that contributes flow generally water to a common outlet as a concentrated drainage. Watershed, it means it is when the meteoric water comes and then touches, or the atmospheric water comes and touches, or the rainwater which comes and touches on the surface of the earth, it started moving with respect to the slope. And then where from the first point to the last point, you just make a basin, a watershed, that is, I mean, from the inlet to the outlet as a concentrated drainage. It can be a part of larger basin, or it can be a smaller watersheds, also called subbasins. Okay, there are you can also use many words like basin, subbasin, watershed, mini watershed, micro watershed. What does it mean? It is based on the drainage, the atmospheric water and its collection in a particular area. There are two steps involved in preparing the watershed map in ArcGIS. The first step, you have to prepare DM raster data, which you have already done it in a separate exercise. And then you have to create a watershed from shuttle radar terrain mapping databases using hydrology tool. It means the tool contains a number of sub tools which has got a lot of applications. I request all the scientists who is working with water resources could be able to explore much on this so that we will get a lot of results. I am also working on this area, similar areas, application of this technology for water, this technology for disaster, and this technology for climate change. And now I am opening the DM data. So this is the data which taking it from that. So once if I am giving add, the data is coming. This is the SRTM data, DM data. And you see the values ranging between 3 to, you can change the color, view of the DEM data, SRTM data. You can change as your wish normally. So this now go to, so our tools. In the spatial analysis tool, there is a subtool called hydrology. There are many options of hydrology. And now we are going to create watershed from SRTM using hydrology tool. That is our exercise now. Hydrology tool. We will see one by one to these tools, how these tools are being used. Fill, flow accumulation. Double click fill and give the data sets, the source data, and output file you fix and then give OK. Now it takes a few seconds for the process. You see, this is fill. Fill with respect to the water is concerned, and now you just open the tool, same tool, and you see you can also find the flow direction. Take the source data, then output file, and then see, and you will get the flow direction of your water body. This is the flow direction from 1 to 128. The other thing that we have prepared maps, we superimpose and then check how these results are going to be extracted for our study. And you also can do flow accumulation. Again, flow accumulation also you have to give the database flow direction fill and give OK. It's all by a single click from SRTM data. Now it's in process. You see at the bottom, flow accumulation is in process. It takes because it's a huge area. Now it is calculating the flow where it gets accumulated. It will buffer the accumulated region and show. You see, this is the flow accumulation. Most of the water is getting accumulated here. You can also classify this in your segments symbology. You classify into various ranges. Suppose if you are familiar with your study area, if you have done a lot of field work is must for any studies which you have do. One is a pre-field validation during the work and after field also we have to do. Only field, you see, you can now get a lot of accumulation zones. And we have done flow direction and accumulation. We also can do basin. You can buffer the basin by using this. Right, you can give the data flow direction fill for the preparation of basin. You click based on this. The system will, you see on the bottom, it is in process. Preparation of basin demarcation. Basin is now prepared. You see it is under process. Look at the top, it is under process. Now it takes time and then it will give you. Now still it is in process. You see at the bottom, it is still in process. It has to do it for the whole area. That's why it takes little time. Now you see, it takes less than a minute to. Otherwise, if you do manually, it will take months together to classify the zones into basin, sub-basin, watershed, mini watershed, micro watershed. But the system takes only less than a minute and then gives the result. You can also superpose. You can you can change the color and you can also superpose your drainage direction over this and then check. And if suppose if you have digitized drainages from the survey of India to Koshit also, you just superpose and check. The accuracy is very much high. And this is more, sometimes we do error in during digitization also could be rectified. When you do it, you just open your raster to polygon. This is raster data. Again, that is one conversion, that you convert this into a polygon and then you will know the area of the subbasin. It is raster to poly in process. So now it is polygon is constructed. You just check, select the field individual feature, so it select as a polygon. Now you will be able to get the area, what is the basin size. And you can also extract the basin with respect to the watershed. That also we can do. That is the another interesting. So data, export data, you can export only this basin. I am now selected portions I am now extracting. So basin, maybe I'll put one shape, extract. You save it wherever you are keeping all your data. So now it is saved. The separate file has come. You just switch off the overall file and then check. Maybe only one basin is there. Now this you make it hollow, and what you do, you just superpose over the map and then you will check. No, because of black and color it is not looking. Take red and then give OK, and you see, zoom it and then check the flow direction. Exactly, this is divided. Exactly in the middle it is divided. So this is the capacity of the RGA software. The accuracy is more in terms of spatial dimension is concerned, as well as the time of the work also is very less, instead of doing manually digitizing the objects. Now you can also, I mean, select both the, what is that, this one, drainages, then I mean, split the drainages into your polygon. Because of raster calculation, you take map algebra. In the raster calculation, you can take it out the flow direction fill or flow. Yes, this one. It is 5,000 plus 0 to 5,000 and 5,000 above. That is flow accumulation. Almost 5,000 plus. It is more than 5,000. You just take 5,000. Yes, that is there. Flow accumulation is more. 0 to 5,000 is less flow accumulation. Give OK. So in process raster calculation, it means it is being, I mean, removed the 0 to 5,000 value. It takes only the highest value. You see, now raster calculation is done. One for the value above 5,000 and other values are 0. It is there in the spatial analysis tool. These tools, all the tools are very much interesting, and we can extract a number of applications through this. Now from raster to polyline, because you want to make the rivers into a polyline, you give your, what is that, I mean, raster calculation value, and you make this as a line. Now give output, and then environment also you will have to output. Suppose if you want to extract with respect to this polygon, you can also give the, I mean, field option as a polygon, and in the environment you give your processing unit as what is that, the basin, same as layer basin, and you also can select the raster analysis. The basin is the mask to extract with respect to the extracted basin. Now you see that it is under process raster to polyline. So this is now taken only this area. What is that? The polygon, because I have asked only this area, it takes only this area. So all your operations are coming. Union, split, but this is with respect to raster data is concerned. So now look at that, how these data sets are. Now this is the data sets of a frame, and here this is the polygon of extracted region, and the drainages polyline also is extracted. Now you just see your river drainages. Now you check with your digitized drainages from the Survey of India toposheet, and then match with this. Sometimes you'll be able to get many other information too. Now you can extract, you can also split the input feature as a polyline. Input is and the split feature is your basin. Yes, I am now going to take extract from the basin, within the basin itself. You can select a field, that is optional. Basin is one, I think it is reverse, we have to select. Basin here, that's what I said. Initially, I thought that it has to be. Now click OK. Both are same, then why it is not working? We'll take clip and then see that whether it is taking. Clip, my input is raster, clip is basin. Give OK. Yeah, we should not do clip splitting. We have to do. Yeah, now it has come inside. You see now how that the basin is now, I mean, taken with respect to drainages within the basin. So this is how you can change the color of this basin as a blue in color as you wish. Now the basin color also you can change. Basin also you can fill. Now this is the steady area of a small basin. You can do your research in this basin. So this is how a hydrological tool is being explored in ArcGIS. There are many more applications in the other tools like in hydrology tools. So I request the water scientists those who are working with may concentrate on this and how to do all this I mean extraction and all that we can be able to do it with this. And you can also drap over the SRTM data, and then this also will give you which area is plain, which area is not plain. So with this the creation of watershed from SRTM using hydrological tool exercise is come to an end. Thank you very much.